We're here today to tell you how built-in intelligence powers Azure SQL Database to help you achieve great database performance and spend less time and energy managing and tuning your databases so you can focus and spend time where it matters, building and running great applications. My name is Vladimir Ivanovic. This is my colleague Dražen Šumić. We're both program managers in the SQL Server product group, working on Azure SQL Database and SQL Server. All right? So let's talk a little bit about evolution of relational databases. Everybody who tried to build a database application over the past 30 years had to solve a number of database-specific problems and challenges in order to be able to do this. Building database applications and running them is everything but easy. There's a number of things you need to take care of. Hardware, software, backups, provisioning, monitoring, tuning, high availability, disaster recovery. These are all some of the areas where we need to spend a lot of time and energy. So what has happened recently in the past 5 or 6 years is Azure SQL Database makes this much, much easier. It takes away some of these problems and solves them for you. You no longer have to worry about hardware. You don't need to worry about software and upgrades. High availability, disaster recovery built in. Patching, built in. Security, built in. So this makes building and running database applications significantly easier, but it's still not exactly easy, since there's still a number of things that developers and IT pros need to take care of. What is the right database size and SKU for my application? How do I scale up and scale down as my workload evolves? What is the optimal set of indexes and the optimal database schema layout? Should I go in memory? Should I use column store? How do I monitor? How do I keep my database performant and available at all times? How do I prevent incidents? Well, the good news is this is all about to change, and thanks to built-in intelligence. Azure SQL Database is evolving to become a service that can do all of this for you. So Azure SQL Database will help you monitor your databases more effectively and easily, tune them with just a couple of clicks, choose the optimal set of SKUs to minimize your costs, and make this all built in. And the great question to ask here is, why is this happening now? This automatic tuning is not exactly today's news. There's been research papers and science papers for the past 20 years describing how a system could auto-tune itself. And cloud is the answer. This is all made possible by the fact that we can now understand how our users are using the database, collect enough telemetry to fuel our tuning models, learn from millions of databases that we run today, improve and refine and sharpen those models to provide tailored and customized recommendations and improved experience to each and every database in the service. So today we're going to talk about the Azure SQL Database performance portfolio. There's 3 layers to it, or three areas. One is insights into database performance. There's 2 different components providing this. Query Store. How many of you have heard about Query Store? Quite a good number. So Query Store is a built-in component, comes in SQL Server 2016. It's also part of Azure SQL Database that collects all this telemetry we need to provide the tuning. It's essentially a flight data recorder for your database. It makes all of these other features available. It's a foundation in this intelligent database story. On top of Query Store is Query Performance Insights built into Azure Portal that provides the top insights built in for you to quickly and easily assess the health of your database, how it's performing, and give you pointers on how you can tune and improve your app. Second part is the tailored tuning recommendations. We have a feature called SQL Database Advisor that provides tailored recommendations based on your historical usage, not best practices, to help you get the most out of your database performance. Recommendations are adjusted as the usage and application evolves, and they're easy to implement and validate. And finally, the last piece of the puzzle is automatic tuning, which is you can tell Azure SQL Database, you can control the policy to tell it to tune your databases automatically. So as the recommendations are being published, they'll be automatically implemented. So you can just sit back and relax, and your database is going to run at great speed. Moreover, intelligent tuning allows you to scale better. So it's actually easy to manage this for hundreds or thousands of databases, whereas it'll be much more difficult for human to have to do that. So for today's session, we prepared a case study that explains and exercises some of these features. So I'll take it over to Dražen to explain this.
Thank you, Vladimir. So before we start, I'd like to do a mini poll just to get a better feeling of the audience. So basically, how many of you are using Azure SQL Database today in some form, dev, test, or production? Okay, so it's a pretty high number. So I assume we don't have to go through the basic concept. I know that some people are not quite familiar yet with how the managed service works. So we will assume some level of knowledge here, but we'll make sure that we explain what we're going through. So we have chosen this form of presentation today where we're going to talk about an imaginary customer that's based and modeled on our real customers. And towards the end of the presentation, we're going to show you 3 customers, their quotes and info about how they're using Azure SQL Database and how they're using the features that we are going to go through today. Through the session, however, we're going to talk about a model customer codenamed Rimini, and we're going to base our story on this customer. So I'm going to start by explaining who Rimini is, who this team is, what they're trying to do, and what are the challenges they are facing. So Rimini is an enterprise resource planning solution provider for small to medium businesses. They have a traditional application with a SQL Server as a data tier. It's working out on-premise. They have a customer base on-premise. And lately, they're moving to cloud. They are basically transforming their solution from the traditional model into a software as a service model. And why are they doing it? Well, they're transforming their license-based business model into a subscription-based business model. This essentially will allow their customers to more easily pay as they go and as they use this service, right? Then they're also going to probably build a web-based front end for this service. And they're going to handle a new customer coming in after the customer creates an account on the fly. They're going to provision the resources for the customer in the cloud backend. And basically, the customer, once they come to the website, they can create an account. And in a matter of minutes, they are operational. They can start using the service. So for Rimini, this is very attractive. It's a new business model. It's a new business opportunity. For their team, it's very attractive as well because they are developers. They are developing this application. Cloud and software as a service model will give them easy deployments, easy updates, and essentially they'll have their entire customer base in this service at the latest and greatest version. And they will provide them a fully managed service, which means they'll be able to more easily monitor what's going on with the service and provide some kind of SLA to their end customers. Now, they have chosen a database per customer model, which will help them really easily solve user isolation in cloud. They may have some end customers who are concerned about moving data to cloud, having data there. And essentially, they're saying, OK, where does my data land and how other people's data interferes with it? Well, with the single database per tenant model, the data is isolated. Every customer gets a database for them. This is great in terms of isolation. However, it will probably lead to Rimini having thousands of databases in the service. And it will create some management at scale challenges on the other end. These databases will have peak and valley usage patterns because essentially Rimini has no idea when customers are going to use this application. Persons in their end customer teams will use this ERP app whenever they want, according to their habits, business hours in different time zones. So they need to accommodate for this varying pattern But then again, they're also cost sensitive. Rimini is cost sensitive because ERP is a very competitive market, and basically they can charge their customers a margin on top of what the cloud infrastructure costs them. So naturally, they would like to drive the cost down so that they can charge less their customers and be more competitive. This means that for all of these databases, they're idle, and then they peak sometimes. They don't want to over-provision resources and provision them for peak workloads. They need to be smarter than that, right? They need to find this computation that basically allows them to work at scale and have provisioning resources for a statistical case of the average or more than average usage throughout their customer base. So having said that, a question for Vladimir, basically, how does Azure SQL Database help Rimini handle this challenge?
I think Azure SQL Database is a perfect fit. Think about this for a second. So if you were to build this on-prem, you had to support thousands of customers, database per customer. How would you build this? How would you run this? How much hardware software would you need? How many people to build it, to deploy it, to run it, to monitor it, to provision it? Hold that thought. So how do we build applications with hundreds or thousands of databases cost-effectively and easily in the cloud? First off, we have a database for one customer. Customer 2 may need more resources in different times. We can have many customers. If we use the single database per tenant model, we will have to provision each of these databases for peak workload of that customer, which leads to a lot of waste since the resources are not used when that particular customer is not active. In order for you to be able to run this cost effectively, we've created elastic database pools, which is essentially a resource container where you can put many databases, allowing them to share resources between them. How many of you have heard about elastic database pools? Oh, quite a few. That's great. So for pools, same as for the individual databases, you can choose between basic, standard, and premium SKUs. And you can also control, when you create the pool, you can set the pool size, which is the total quantity of resources you have for all of your databases. But you can also control the per database minimums and maximums, allowing you to fine-tune how much resources each and every database can have. And then databases can essentially leverage the fact that not all of them are likely going to be active at the same time. Rimini customers are globally distributed. Their working hours are different. Their working patterns are different. Their industries are different. So there's high potential for reuse. With this in mind, elastic pools are the perfect solution, both for multi-tenant applications such as Rimini, but also for customers that have many databases which are not constantly active or active at all times. Here's what you get with elastic pools. It allows you to cap your spending. It allows you to share resources and have more effective, maximize your utilization. It allows you to gain customer isolation. And finally, it also provides easy management at scale, since you can manage your pools. You can manage hundreds of databases through pool interfaces, essentially cutting your management efforts and making it easier to do. Now, the challenge here is which set of pools is the right for my applications? How much resources do I need for a given set of databases? What parameters should I choose, which is optimal based on the particular resource utilization of my applications? And it's not exactly an easy problem to solve. So we'll build an advisor that does that for you. And let's take a look at how that works and why is that so important. So let's assume that this is the usage of one of the Rimini databases. And this goes back from real-world telemetry. So this one database occasionally peaks up to 90 DTU, has some smaller peaks, but is mostly inactive a lot of times. So if we had 4 such databases, here's how that will look. So they could still very effectively use the same set of resources because they're not always active at the same time. And finally, for 20 databases, we can see that essentially all of them could fit into a 100 DTU container. This is an exaggerated example, but it gives you the idea of how much reuse can essentially be achieved for databases which are not constantly active. So this allows databases to share resources and relieves you of a burden of looking at which databases to combine. System does the analysis for you, including identifying what is the right pool size and which parameters are optimal. And now we want to show how easy this is in the demo. Thank you, Dražen.
Here it is.
Yep. So this is Azure Portal. I suspect a number of you are familiar with this. We're going to open up a server that I have. I have 64 databases on this server. Some of them are in the pool, some are not. The system has analyzed the utilization for these databases and has provided me with a recommendation here. I'm going to zoom it for you. That says, we have a recommended elastic pool for you. Click here to learn more. Clicking here, I can see that the system recommends, one sec, I need to scroll this a bit so you can see better. There it is. The system recommends that I should create a pool of 24 databases. That is all of the databases which are outside of the pools currently. It's saying that a 400 DTU pool is enough. And currently, each one of them is using 100 DTUs just for itself. So instead of 24 by 100, I just need 400 for all of them. And that will provide me with monthly savings of 2.7K. That's great news. I love that. Clicking here, I can see the parameters for my pool. System proposes a 400 DTU pool, which will cost me $900. So instead of $3,600, I can now cut my bill to just $900. Opening up to explore, here's what happens. This is a bit busy screen, but we'll explore it in details. This is the summary of the analysis that the system did and provides me with feedback and why is the 400 DTU pool the right for me. So on the left-hand side, this line is the combined resource utilizations for the 24 databases that are proposed to go in the pool. For the past 2 weeks, these databases together needed between 100 and 200 something DTUs. So given that the peak is above 200, system is conservative and proposes, this purple line here, proposes a 400 DTU pool for these databases. On the right-hand side, we can see the per database utilization for each of the 24. As an example, for this first bar in the series is for a database called Demo Telemetry DB, which has a 100 DTU peak and a very small 0.32 DTU average, essentially a perfect candidate for pools. And a couple of other ones also peak at 100 DTU, but use on average far less than that. And you get the idea. So you can see exactly how much each of these databases is contributing. So now let's do something fun. Let's assume that I don't want these two databases to be in the pool for whatever reason. And let's remove them. Here I can see the table basically with all of the databases proposed to go in the pool. And I can sort this by peak DTU. So let's remove 2 of the databases. One sec. Sorry about that. And I'm going to zoom this in so you can see better. Oh. Apologies. we're back where we started. There. I'm going to remove 2 databases. Let's remove one more. What I want to show you is this. As the database utilization for the selected subset, we now have 20 databases in the pool. I need to remove a couple more, sorry. Perfect. So now we have 18 databases selected to go into pool instead of 24. What has happened on the left-hand side is this line, the combined resource utilization, is now adjusted. And so is the recommendation. As you can see, system now recommends a 200 DTU pool based on the configuration of the databases selected. And we can do the inverse and add databases to pool, the ones we just removed. Recommendation goes up again. So this is dynamic feedback for you. It allows you to quickly understand what is cost effective. You can customize it to your needs and be done.
So maybe it's important to recap here. So basically, the recommender will not always recommend you to put all of your databases in the server into the pool. What it essentially does, it has the historical data on usage throughout the last 14 days. And then it runs combinations of databases to see basically which set of databases fit together well in this pattern. And they could be fit into a pool so that they don't fight each other too much over the resources of the pool. And then it looks at 90th percentiles of activity of those databases, not exactly peaks, but like 90th percentiles, and then it has a safety margin on top of that. Basically, it will over-provision to some extent. So in this example, there is no 300 DTU pool. We don't have it in the offering. Mm-hmm. It would have probably recommended a 300 DTU pool for databases that have a peak around 208. But in this case, it had to go to 400. Maybe you know a business logic why not all of these databases should be in the pool. Maybe you can remove some of them. Maybe some others need to get in. And basically, the system will on the fly adjust its recommendations. And basically, you can use it as a on the fly recommender for creating pools. Yep. That's kind of the...
Yeah. One additional idea here is, let's assume Rimini has gold customers and silver customers. But gold customers pay more, get more features, and should get more performance. What they could do is create 2 pools and limit one pool to, say, 20 DTUs per database max, and make that be the silver pool for silver customers. And then there'll be a larger density in that pool, and they'll cost Rimini less compared, for example, to the other pool for gold customers, where DTU cap can be 50. And there, in the similarly sized pool, you can put fewer databases with larger peaks or more databases with smaller peaks. So it's all flexible for you, but the point being is you're now in control. System helps you do the cost-effective thing, but it's still you who can customize and tailor this to your needs. One more thing we need to do here is we want to show you how easy... we're going to take questions after the talk. Apologies. One more thing we want to do here is we want to show you how auto-tuning works for the pools. So we now need to just start auto-tuning. And let me explain the setup first. On this same server, I have 2 identical pools created. One is called Elastic Pool Auto-Tuning Off, and the other one is called Elastic Pool Auto-Tuning On. Each of them has 10 databases inside, and I have run a workload against both of these pools. I have a small app running on a VM, nothing fancy, just firing queries against these two pools. So it's essentially round robin. I'm targeting 10 databases in one pool with the same workload, 10 databases in the other pool. What we try to do is simulate a real-world scenario where you create databases and then start running whatever the app is. Now, these two pools, we're going to turn on auto-tuning for one of them, and the other one is going to it won't have auto-tuning turned on. And let's see how the performance for the queries is going to look after, towards the end of the session. So now I'm going to go to PowerShell and enable automatic tuning for one of these pools. This is a really simple script that allows me to do it. I need to pick the subscription. I need to set the server, resource group, and the pool. We're going to enable automatic tuning for this pool, automatic tuning on. And what this does is essentially collects all of the databases on the server, and a for each loop will just call these two methods. And it's a little bit longer call here, but this call set Azure SQL Database Advisor auto execute status, a mouthful, but still, will essentially, for create index recommendations, change the status to be enabled. And also for drop index, same thing. So instead of me going through the portal, turning this on one database at a time, I'm just going to have the script do that for me real quick. Three, two, one, go. So we're getting the list of databases, and shortly it'll start enabling auto-tuning. DB31 enabled, DB38. So this will finish in a minute or so. So we wanted to show you live on stage, right here, right now, what effects this will have. And we're going to go back to this and see what the results are in 30 minutes or so towards the end of the presentation.
Okay. Going back to the slides. So basically, a short recap. We've seen here how you can how you can first use Elastic Pools to get a good price to performance equation for some of your workloads, and in cases when you have more than many databases. And we've seen how you get recommendations either when you're creating pools or when you're changing them afterwards from the system based on historical usage of all those databases. Basically, which ones fit best if you want to max out your resource usage. Now going forward, let's look at insights into performance. So not everything works well always, right? There will be performance incidents. There will be bad deployments that cause some sort of issues in the service. There will be some necessity to look at how performance is of the database, and then basically try correct and fix things. And for this purpose, Rimini is of course interested in doing monitoring and troubleshooting of their service. Remember, they have offered a fully managed service to their customers. So it's no longer a responsibility of the customer to make sure that it runs somewhere on a box in customer's data center. It's now their responsibility. They are running it in the cloud, and they're offering some sort of SLA to their customers. In a way, we are doing the same thing for databases, Azure SQL Database and all other managed cloud services. So this can be hard. Rimini team is asking themselves, are there any performance issues with my databases right now, or are there some coming? Maybe things are getting worse and I should know about them. What is the time to detect those issues? What is the time it takes me to mitigate them? And then basically, what is causing the problem? How do I trace from the workload and the symptoms I'm seeing there, how do I trace back to the application? How do I fix things as quickly as possible? And there's either reaction to incidents and then troubleshooting of incidents, or I can also be proactive. I could look at my top resource consuming queries and workloads, and then basically see what's rising over time and see if my databases are coming close to their limits. If they come to the limit, things are going to start to break down. So we better avoid that. We always want to be proactive and learn about these issues before our end customers, and basically try avoid our end customers even knowing about them, right? So having said that, let's take a look into the features that SQL Database offers Rimini to handle these issues.
Thank you. So this is a classic performance incident situation. Customer sees that the application is slow or unresponsive, calls customer service, developer, IT op, gets woken up middle of the night, scrambles, tries to find what the issue is. Totally reactive, lots of anxiety in there. Surely we can do better. Turns out we can. The key to this is Query Store. It essentially allows you to have the right data recorded proactively. Before Query Store, when there's a performance incident, you had to essentially go fire up a profiler session, hope that the issue repros again so you can capture the trace, go and analyze it, and find and fix the problem. Right now, that data is collected proactively for you. It's been made available within the database. It's highly available, so survives failovers, memory pressure, everything. And there's algorithms in there that make sure that you have the right subset of the data captured continuously. So if and when an issue happens, you know that there's data in there to help you troubleshoot. Query Store is accessible through T-SQL and also has a very nice SSMS UI, the Management Studio, essentially the database developers and DBA's tool of choice. And in addition to that, helps you find the key performance, the performance profile of your application and key things to look into and optimize. Now, Query Store does require certain proficiency with databases and how they work, query performance plans, etc. So this is essentially an expert's tool. We have built Query Performance Insight in Azure SQL Database portal that essentially helps you get to the insights and relevant parts faster. So we will analyze the Query Store data and provide the top insights built into the portal for you so you can find them quickly and get right to the problem within seconds or minutes when it appears. So developers now, or the IT professional, whoever is watching over the app performance, can quickly find the right source of the problem or the thing to look at. As you can imagine, Query Performance Insight works on top of Query Store. It has a really easy and intuitive to use UI in the portal and provides top insights for your workload. So resource utilization, how many DTUs are being spent by each of the queries. It gives you a resource breakdown. Is your application CPU heavy or IO heavy? It makes a great deal of difference in terms of how you will tune it. And also provides duration and execution counts, helping you tie the queries to your application. So essentially, we want to make it easy for you to go from database performance to improving your application and helping your users quickly. So without further ado, let's see how that looks in the portal. Again, we're going to start off from the home page and open up one of my databases on my server. This takes a couple of seconds to load. But what we want to show you today is the performance dashboard for Azure SQL Database. This is the one place for you to go and understand, first off, what is the current performance of your database. The red line is the DTUs, how they are being spent, and the bars below are the top 5 queries in terms of resource utilization. So you can see how things are running now. My database is hitting peaks occasionally. So if I had a customer reported incident around this time, I can quickly understand what the problem is. In addition, I can also see the active recommendations from Database Advisor, and the top ones are called out here for me, and I can access them real quick. We'll get back to this later on. And I can also see the summary of automatic tuning for this database. First off, at the moment, 0 out of the 2 auto-tuning advisors have been enabled. Both the create index and drop index are off. And this is a breakdown of tuning activity for my database. So there was one automatic action and 2 manual actions for the past week. For the moment, let's explore the query performance insight. So assuming that I had a customer reported incident around this time, let's try to figure out what the source of the problem is. And from this graph, it's fairly obvious that the yellow query is essentially responsible for most of the resource utilization. It's the query ID number 151, which doesn't tell us a lot. This data comes from Query Store. But I can click here, and I get the T-SQL text for the query and a detailed performance profile for this query for the past 24 hours. And this is all customizable. You can choose different aggregation types, different intervals. So it's really easy to get the key questions answered quickly here. Something we've shipped recently are the 2 additional views in Query Performance Insight. One helping you identify long-running queries. And again, our friend number 151 is the culprit in this view as well. So we should definitely take a look at that. And you also have an option to customize this view. And this one is really interesting. I really love it since it allows you to freely choose which metric you would like to take a look at, what the period is, what number of queries you want to take a look at, and also which metric. So for example, we can choose to see what happened in the previous week and look at top 10 queries instead of 5. And that's all available in one click. So for me, and I've started my workload on this database a couple of days ago, so there's nothing much past the previous couple of days, zooming to the last 6 hours. You can see how easy it is to just open the portal and it hits you. The most important things are fairly easy to discover. And here I see the key stats for my top queries. I can sort this by CPU, or by duration, or by execution count. Now, let's assume for the moment that I want to learn more. I want to take a look at more details. For example, I'm interested in a plan for this query. And in order to do that, let's look at the Query Store data directly. So the second step here could be to just open up SSMS. And we've connected to the same database. Let me zoom in here. All right. So I'm connected to the same database. And this comes new with SQL Server 16 and Azure SQL Database. As you can see, under my database, CRMDB, there's a node called Query Store. So let's see what there is. Hiding in here are again, the top pre-baked views to help you understand the performance of your database in greater detail. So opening up the overall resource consumption view, here's what we get. We get a breakdown of duration, execution count, CPU and logical reads for last day for our database by default. And again, clicking here, I'm getting even more details. So let's take a look at what happened around this time. I'll zoom it in for you here. I see the top 25 resource-consuming queries for the last day. And again, we can see the query number 151 being the clear top resource consumer.
This is no surprise, of course, because the same data is being used under the hood, right?
Right. So this, we've expected that. But now, here's where more data is available for further analysis. So this query this is the plan summary for that query. This query has been using just one plan for the past 24 hours. And here we have that plan pulled out. So you can quickly see why is this query taking so much resources and so much time. How many of you have done query plan troubleshooting? Okay, so this is all familiar for you guys. Essentially, up until a year ago, you had to spend much more time and effort essentially to capture this data. And it was very hard to capture it proactively ahead of the incident. Now, whenever it happens, you can rest assured that the right data is preemptively collected and it's available at your fingertips. So there's a deep dive session for Query Store in the Ignite program. It's on
yesterday afternoon, tomorrow afternoon,
yep.
Of course.
It's
Not
Thursday
yesterday.
afternoon. So if you want to learn more about Query Store and advanced performance troubleshooting techniques, that's the session to go to.
Yeah, our colleague Borko Novakovic is doing that one. So let's take a step back, basically, and after seeing the insights, of course, it's great seeing that the system will give you the information you need. If you know what you're doing, if you want to figure out and solve an issue quickly, it's always good to have good information timely, and so you can take action on it. Now, in the managed service, we should do better. Basically, the managed service should be able to do better, having in mind that all of this data is already there running through the system. There's lots of telemetry. We're monitoring it anyway, right? So why not try automate some of these things? Why not try close the loop and not only create insights that should lead you to action? Why not recommend the action and maybe do the action ourselves? To try close the loop completely and eliminate the incident as it started happening early in the phases when it was building up. That's what the next section is about. Rimini and perf tuning challenges. Rimini is obviously motivated to tune performance because of two major reasons. Better performance means their customers will get higher responsiveness in the application that they built. Those queries will run faster and they will have interactivity in the tools. Not good when a customer is waiting for 10 seconds for a query to return when it's supposed to be interactive. And obviously, if they manage to lower the resource consumption in the application, the databases that they're using in the cloud are of higher value to them. And it really relates to their cost. Because if there were queries that were using 90 DTUs and you get those down to 20 or 30 DTUs, you can now potentially choose a less expensive database in the cloud to use for the same purpose, right? So there's a cost equation there as well. In terms of perf tuning challenges, Rimini is facing all the usual challenges. Tuning requires SQL expertise, domain knowledge. Many companies out there do not have dedicated DBAs to look at all of these databases, or if they have them, there's few of them. They have lots of things to do. So basically, not every database can get attention. And then, regardless of the level of skill, tuning takes time and effort. It's time spent on something that maybe should not have been spent. As a result, most people do tuning rarely and reactively, only when trouble happens, and not really proactively. So it's really hard to scale your team. And for example, for a customer like Rimini, having thousands of databases, pay the same amount of attention on that growing service and that growing data tier. So there's definitely management at scale issues as well. So how about Azure SQL Database doing something automatically for Rimini team and basically recommending them what to do to tune the performance?
Yep. So continuing where we stopped, in addition to running Query Performance Insight, creating top insights for you and helping you identify what the solution is, we've built advanced tuning models that'll analyze the telemetry, analyze your database usage, and provide tailored recommendations on how you can improve performance. So in this case, our friend developer or an IT pro doesn't have to fix the problems. He just needs to review the recommendations and choose which ones to apply. Recommendations tailored to each DB. Again, these are not best practice recommendations such as turn on feature X, Y, and Z. It's a good thing to do, no. This is database A needs a thing B based on how it's being used. Recommendations are adjusted automatically as the application evolves. In today's world, where deployments are a thing that's done daily, a couple times per month, instead of just once per year, it's pretty much impossible to afford long performance testing cycles before each release. Things do slip through, and things evolve over time. So this is a great mechanism to make sure that your schema and your database configuration is optimized for current usage. And in addition, Service makes it very easy to apply these recommendations. If you had to do this manually, typically you would have to wait for a maintenance window, baseline the performance, apply the recommendation, measure some more, etc. So it takes hours, if not days. It's stressful. Happens off work hours. Instead, you can just tell the system to do all this for you. System will baseline, implement, measure once more, understand the difference, provide the report, and very importantly, if for whatever reason the recommendation turned out not to have positive impact on the performance, it'll roll it back automatically. So if database usage changes quickly, there's the feedback loop to help the system understand that and recover. So your performance can only get better. And as before, it's really easy to use from the portal. So let's take a look. This is where we left off, the query performance inside. But now I want to draw your attention, not to this thing, but on the purple bar at the top. So I have recommendations to improve my performance from Database Advisor. So let's go on and explore those. This is the Database Advisor interface. And it essentially has two tables. One, the table at the top, has active tuning recommendations for my database. There are two different create index recommendations, and they are one each of parameterize your queries and fix schema issues. They are sorted by estimated impact to my workload, so I should always take a look at the most impactful first. The table below is the history of tuning actions for my database, and I have 3 successful implemented indexes, index recommendations for the past week. So let's explore this first create index operation. I will zoom this in for you to make it easier to see. There. So it's a high impact recommendation. It will require 128 megs of space. It will create a non-clustered index on the employees table. It'll add columns city and state to the index key, and it'll also include a column called postal. It's right below. So I can understand what index is going to be created. And moreover, I can take a look at the index script. So here we have the T-SQL script that the system will execute on my database. So it'll create a non-clustered index with this funny name on the database with including columns. But the important part I want to draw your attention to is the online equals on. What this means is, I think most of you already know, but it's important to call out. All the tuning actions are online operations against your database. So your normal workload still goes on. Tuning does not interfere. There will be no locks other than one small lock when the index is complete. So this operation is not blocking, and everything Database Advisor does is performed as online operation. One additional thing where the script is useful is if for whatever reason you need to create this index manually. Scenario for that is, for example, you want to change the name, or you want to customize the list of columns. 2 clicks, you can get the script, open up your tool of choice, Management Studio, for example, customize the index, create, go on. But we recommend creating via Database Advisor, and the main reason for that is you get all of the benefits of the managed implementation. So you don't have to worry about performance measurement, automatic rollback, have the service worry about that. This is also useful if you want to include the index in your database scripts or in your source control. So let's go on and implement this index. There's an apply button at the top. I get a confirmation dialog that's telling me, hey, this will create an index against your database. Do you want to continue? But more interestingly, it gives me the option to automatically create indexes, apply create index in the future. So this essentially turns on automatic tuning for my database. So let's go on and do it. What will happen now is both of the create index operations from the top table are now listed as pending operations. One that I've created manually, which is this one, employees, and one because I've turned on automatic index creation for my database. And you can access that through this option. So we can see that now I have create index turned on for automatic index creation. There. So quick recap, tailored recommendations, easy to access. You're in control again. If you need to customize, you can do it. Or you can rely on the service to do all of the work for you. You just need to review and apply. I also want to show you how this looks on the dashboard. So we want to go back to the performance dashboard for this database. So now I can see that I have 2 recommendations remaining, and one of my advisors is in auto mode. And there are also 2 tuning actions in progress. So again, full transparency and easy way to understand what's going on.
Okay, moving on.
Yep.
So basically, we already touched on automatic performance tuning, and this is the part where basically the system will just automate the loop that you've just seen. The loop of coming up with the recommendation, then you can take a look at it, use it in any way you see fit. And then if you click apply, then essentially it's a managed implementation where we first baseline the performance in higher level of detail, or we already have it because a query store has been turned on. And by the way, query store now is on about 98% of the databases in SQL database, and very soon it will become the default configuration that's going to be on there for every new created database. So this baselining process will already be there, very likely, when this index gets created. And historical data about the workload are already in the query store for the instance. Now, during the application, performance will be measured in terms of global performance and also in terms of impacted queries. There's an estimation of what queries will be impacted by a certain index. Same goes for parameterization as well. And then there will be points in which system will evaluate the index, and as long as it's good, it's going to leave it there, keep monitoring it up to 7 days. And then if it's not good, it's going to quickly revert it back. So that there's no, even if it's inconclusive and it costs to maintain to some extent, it's going to revert it back. It just keeps the useful indexes performance-wise. So automatic tuning, we already said this kind of, is good to be offered to Rimini. Rimini has obviously some DevOps challenges. We mentioned thousands of databases that they need to monitor and manage. They need to react quickly, 24/7, because it's a running service. People are using it day and night. And basically, they need to support different usage patterns. No 2 users are using the app the same way. There are applications, for example, where users can also customize the schema to some extent for their own databases. So automatic tuning is something that could take this into account and then basically adjust the schema to each individual database according to the way the end user is using the database. So back to you, Vladimir, just do a short recap basically of what we've talked about automatic tuning.
So the key parts about automatic tuning is we want to eliminate the human out of the loop for 2 reasons. One, so you can focus on other aspects of your work. But the other one is that machines are quicker to react than humans and scale much better. At a point where you have hundreds or even thousands of databases to manage, you need a team that does just this, performance troubleshooting. And some of you may already have such teams. These people can rely on automatic tuning to help them essentially make sure that the right tuning actions are applied quickly and instantly, and you can then review later on and need it and adjust. But there's real quick feedback, so your users get great performance at all times. And then developers can focus on building great applications instead of making sure that databases are performing. We called this out already, but it's important. So there's full audit log for you to understand what's going on. You can see which actions have been applied. You can take out the script if you need it. It's all really easy. Now, I want to show you what's going on. Let's take a look at what's going on with our demo. So you recall that we've turned on automatic tuning for one of our pools. So I've also built a Power BI dashboard. It's a really simple one, quick and dirty. Apologies for lack of polish. But essentially, the top part of the report is the average query duration for a pool that doesn't have auto-tuning enabled. And the below is the average query duration for the pool that does have auto-tuning enabled. So far we can't see any difference. The averages are about 40 seconds. So it obviously needs a little bit more time. So we're going to come back towards the end of the session one more time to see. But what we expect is that query duration is going to drop here because the system implemented the indexes to help speed up the query performance. Again, we didn't have to do a thing. Enabled auto-tuning, so let's see what happens. Fingers crossed. Back to you, Dražene.
Thank you. So a quick run through customer testimonials. If you see this, you will now. So basically, just a couple of examples of real people using this, so that it doesn't turn out it's just imaginary customers. So basically, but before we go that, just quickly summarize the benefits that Rimini has from these features that we've shown today. So we've shown that they can build a software as a service that scales on demand, handles peak loads. They can do perf monitoring easily and proactively. And they get recommendations from the SQL Database Advisor on how to tune their performance, how to tune their databases. They can also turn this tuning on automatically and not care that much about it. Let it run and then afterwards see how it was doing and review things. And here are examples of some of the customers. So Gibraltar Software is a company that have a software as a service solution. They have it's called Loop. They have a logging and monitoring system. Basically, they give you a API that you use for your app. The app can be deployed anywhere, on premise or in VMs, anywhere. And then the app sends events about what's going on with it to the cloud service that Gibraltar Software built. And then the owner of the app can take a look at this service. They have some analytics on top. And then you can look what's going on with your deployed instances of the application, what state they are in, and so on. And each of their customers gets a database in Azure SQL Database. So basically what these guys are using SQL Database Advisor for is to, as they say, transform their very expensive queries into fast and cheap queries. So they're interested in both making it run faster, but also at the cost perspective of it, like how many resources certain queries are spending. Then DocuWare is a digital document management solution. They're pretty big, based in Germany. They have thousands of databases in Azure SQL Database, the same pattern. And basically, they use SQL Database Advisor to get recommendations about how to keep their databases under control. So not necessarily maxing out on performance. It's basically making sure that they run well as they're supposed to, and nothing goes out of control from time to time, which is very important for them. And then finally, Umbraco. Umbraco is a content management system. They're open source. They can be used on premise, wherever. They power about 350K websites. Recently, they've created Umbraco as a service that they offer out of Azure, also using Azure SQL Database as their backend, Elastic Pools as well. They just put many of the databases for their customers into Elastic Pools and pay for the combined resources. And they, having in mind that they're using the same code pretty much with Azure SQL Database in cloud and Umbraco as a service, as well as for the on-prem version, they're looking at recommendations, and then they're able to improve performance of both versions of their app. The one running in the cloud and also the one running on premise. They are taking these recommendations, reviewing them, and then applying some of them. That's the mode that they're using the system in. There are also public case studies available for Azure SQL Database. Umbraco is one of them that have recently been published for the software as a service type of customers. And let's go to the technical part. I think it will be interesting to show you. Vladimir will show us how things work in the back end. This is basically not magic, it's serious engineering, lots of data, algorithms running, and various moving parts of the system.
Yep, so the automatic tuning is, and most of things that we do, recommendations, is about trust. And we wanted to gain your trust by actually showing you how we built the service and share some of our learnings, so you can understand how things work under the hood. So it all starts with the customer database in Azure SQL DB. And as we told you, in order to provide these intelligent capabilities, it's crucial for us to have quality telemetry stream. And Query Store is our secret sauce. For all related to database query performance, it all starts there. Now, the Query Store data is being fed to our tuning models. They also run in the cloud in Azure. We're leveraging some of our partner services to be able to do this effectively at scale for 1 million+ databases. Again, recommendations are then published to an inside store, and from which you can access it through your favorite medium of choice. Is it Azure Portal, PowerShell, or REST API? So this is the loop that provides the recommendations to you. This is the recommendation publishing service that we run. Then the other part is what happens when you click apply. Then the other service, the recommendation implementation service, takes over. It runs in Service Fabric. Service Fabric has been released. It was developed internally for Microsoft's purposes, then released for everybody else to use. We use it to run the execution service, which will go on, implement and validate that recommendation against the database. And this closes the loop. And again, as the usage evolves and changes, telemetry will adjust, recommendations will adjust, and then the full loop gets exercised.
And of course, it's important to say that this is not real time. So this is why we're checking to see whether those elastic pools are getting the benefit of auto-tuning that we turned on 20 minutes ago. Takes time for this loop to start working, telemetry to start flowing through the cloud backend, some of these algorithms to execute. They identify that there's an opportunity, post the thing to the store, then the thing gets applied, and then we start measuring some results that we hope are going to be positive. But in reality, it's not real time. We are thinking that we are close to something called tune it in a day. That basically, essentially, if you create a database and you start running it in a stage environment of yours or something like that, you should be able to see results within the first day of deploying it. So that's kind of the state where we are now. Of course, we are trying to make it faster and faster so that this loop becomes tighter, and that essentially we can react more quickly to the changes in the workload.
But
Yeah.
The point is, you can run your workload in Azure SQL Database for a day and expect to have tuning recommendations available. If you enable automatic tuning, they will be implementing as soon as they're published, taking humans out of these loop, so you can focus on other things. So this is the recommendation production and execution workflow. We have on-demand insights, which is essentially query performance insight. And it's a simpler but also important part of the service. The flow is like this. You would poll the insight service. It will query your database, do the analysis, provide the aggregated results, and send it back to you. So this is essentially the service that we run. We've built this incrementally using different building blocks available in Azure. That allows us great agility, but also great scale. Because we have just one database on the slide, but there's actually more than 1 million databases that we provide the service for. Another story we wanted to share is about accelerated learning, the speed of evolution. And it's all made possible with this service architecture that runs in the cloud. And here's why. In order to be able to evolve the algorithms and react and adjust find out what the issues are, opportunities for improvement, we're very big and we're strongly leveraging all of the channels of feedback provided to us. So we'll have the built-in customer feedback option on the portal, and we're monitoring this daily. There's, as you can see, about 10 to 15 customer feedbacks we get every week. And that allows us to understand quickly if there are any things that we've missed. And some of the customers have suggested some really good ideas in terms of how to evolve the service. The other part of the equation is real-time telemetry. And this is a snapshot of one of our dashboards that we look at daily. Essentially, it's really easy to understand how each of the pieces is working and where we need to spend our time and energy tuning and optimizing. So again, going back to a world from a couple of years ago, if you're building a product, shipping it on CDs, your time to insight, your time until you can understand how your product actually works, which are the parts of your product you need to change, evolve, improve, time to insight was measured in months, if not years. You ship the product, it gets adopted, customers start to using it, then feedback starts flowing in. For us, we can see the results of what we're doing on a daily basis. Every code change has a telemetry piece. That allows us to evolve real quickly. So let's go back and see how our tuning demo is working. And if the recommendations have already been applied. Zooming in, let me just, I want to refresh it first. But yep. We still don't have the recommendations implemented. So 30 minutes was quite a bit of short, not enough time. What we can do is we can show you the slide. Can you flip back to?
Oh, sure. Basically, how this is supposed to look after enough time.
Yeah, this is what we want to expect, and I'm hoping that this will start to move in this direction real quick. We just need to give it a couple more minutes. But essentially, this is the main benefit. I may not want to, or I can't physically scale to provide a tuning service for hundreds of thousands of databases. So we need to help developers and IT pros be able to provide quality service for all their customers. And machines do this much better than humans.
Shall we quickly recap?
Yep.
And then basically we'll be here for questions, even though the session ends. So feel free to come to us and start a conversation. Yep.
Okay. One additional important point is this built-in intelligence can help any app and every app. You don't have to be on the Microsoft stack. You don't have to use the portal if you don't like it. There's REST APIs in PowerShell to access all that you have seen, as it is with every Azure service. We also integrate with Azure Security Center and Azure Application Insights, but also with the plethora of drivers available for Azure SQL Database, any and every application can benefit from this. I think that's an important point that's really big.
Yep.
So
just a short recap of what we've seen today. Basically, achieving great performance with Azure SQL Database using built-in intelligence. Of course, industry experts can do this better. We're not saying that the built-in intelligence has overpassed humans. We're just saying that built-in intelligence can help you do a significant part of the job, help your life easier, delegate some of the things. That's the state in which it is in. There are actionable recommendations and automatic tuning as options to choose from. So which one fits better, whether you want to review stuff before deciding whether to apply it or not, or you just want to get it to run as quickly as possible in the middle of the night, weekend, etc. Without it waiting for you to review. All of this is supposed to save time and effort, insights features, as well as recommendations, as well as automatic tuning. make it easier for people to use the cloud database service. And as we said, it works if you have a single database. It works if you have thousands of databases. It works for elastic pools. It works for databases outside of the pool. We just picked a customer. That's a good pattern for elastic pools, but that doesn't mean it works only in pools. That would be it. Thank you.
Can you go
Thank
back,
you very
please?
much. I see.
I have good news to share. So, turns out we're not liars. So thank you, Microsoft Cloud.
This is what it means to do live demos on a system. You don't know what it's going to do. So
we wanted to be honest. Here's one of the databases and how it looks. Recapping. So this database is now fully auto-tuned. And here's the point that when I started running the workload, performance of the queries, and here's how it looks now. So an index helped crunch the resource utilization of this query, of this couple of queries into dust. And as a result, our pool is now using significantly less resources, allowing us to either put more customers, reduce the pool size, again, improve our cost profile, compete better, increase our revenue. But on the other hand, I didn't have to spend hours or days doing it. I just turn it on with PowerShell, and there it is. So I'm really happy with this. I'm going to leave it on.
Yeah, it's good that it happened, but
yeah,
okay.
It was a nail biter. It was, but
we like to take risks.
Yes.
Okay, so thank you. Time for questions. We're here, so go on and shoot.
Yep, we'll stay as long as needed. Thank you, guys.
Thank you. Thank you for coming. Thank you.